Okay, today we're going to add area and perimeter to our special right triangles. Now that we know how to do all those radical operations and find lengths, we need to find area and perimeter. So remember that the area of a triangle is base times height divided by 2, or you could say 1/2 base times height. Perimeter is simply the sum of all the sides. So on the right triangle, the base and the height are going to be the legs. So those would be the base and the height. I need to know those lengths in order to find the area. For perimeter, of course, I need all 3 side lengths. And on a 45, 45, 90 right triangle, we're going to start out with 1 side length. So let's say, for instance, I give you this side length right here is 20 centimeters. So I would need to find the length of the other sides. This one's going to involve rationalizing the denominator. Oops, I put the special right triangle table wrong. That's square root of 2, isn't it? So the 20 would go here because it's the length of the hypotenuse. Remember, I always look at the side that the given side length, the angle that the given side length is across from, and the 20 is across from the 90-degree angle, so that's why it goes in the 90-degree column. Well, that represents the length that's been multiplied by the square root of 2, so I would have to divide by the square root of 2. Unfortunately, we don't get to leave it like that. We learned yesterday that if we end up with a square root in the denominator, we have to rationalize, which is simply multiplying by 1. We just have to create that special 1, that's the square root divided by itself. But now that I have that, I multiply numerator times numerator, denominator times denominator. The numerator becomes 20 square root of 2. The denominator becomes a perfect square because when I multiply square root of 2 times square root of 2, I do get square root of 4. And we know that the square root of 4 is 2. So that is the value in the denominator. The numerator is 20 square root of 2. And then I look and see if I can simplify the coefficient. So 20 divided by 2 is 10. So that simplifies to 10 square root of 2. So that's what these two lengths would be, 10 square root of 2. Okay, so the sides across from the 45-degree angle are each 10 square root of 2 centimeters. And now I need to figure out the area and the perimeter of this right triangle. Remembering that area is base times height divided by 2, where these two values are your base and your height. I'm going to say it's 10 square root of 2 multiplied by 10 square root of 2 divided by 2, base times height divided by 2. Now remember what I can multiply here. I can multiply the 10 times the 10. That would give me 100. I can multiply the square root of 2 times the square root of 2. That would give me square root of 4 divided by 2. Well, square root of 4 is 2, so 100 times 2 divided by 2, that gives us 200 divided by 2, which is simply 100. So that did not fit there. So the area of this triangle is 100 square centimeters. Notice that even though we had square roots in everything, because our square root ended up as a perfect square when we combine them through multiplication, we didn't end up with a square root in the answer. So perimeter is simply the sum of all sides. So when I look at the sides, it's 10 square root of 2 plus 10 square root of 2 plus 20. Now I'm going to tell you that the answer here is 20 square root of 2 plus 20. And of course that would be centimeters. And that is the final answer. You might be tempted to combine these two 20s, but we can't do that because those two 20s are not like terms. It's similar to what you did in algebra, where if I said what's 10x plus 20, you would tell me those are not like terms because I can't, one has an x and the other one does not. Same thing here. And the reason I could add, if I had 10x plus 20x, and those are like terms, I could add them because x is a common factor for both of those terms. So I could just factor out the x and say that's 10 plus 20. Distributing would bring me back to the original problem, because that's what factoring is the opposite of distributing. Well, now I see that I have 10 plus 20 in parentheses, so that's 30, and then times x. And that's again because the x is a common factor to both terms. And if I just have 10x plus 20, there is no common factor, so I cannot add those. In algebra, we called that unlike terms. So if I was going to equate that to this would be like the 20x plus 20, where x is the square root of 2. If I had 20 square root of 2 plus 20 square root of 2, I could add those because square root of 2 is a common factor, and I would get 40 square root of 2. A question that was asked in class was, what if I had something like 20 square root of 2 plus 50 square root of 5? Could I add those? And the answer is no, because square root of 5 and square root of 2 are not the same. There's no common factor there. So again, the final answer for the perimeter is 20 square root of 2 plus 20 centimeters. So let's look at a 30, 60, 90 triangle. I would suggest that for the test you have 45, 45, 90, and 30, 60, 90 table ready to go. So you can just use it every time you run into one of the problems. And you're going to have lots of special right triangle problems because it's the special right triangle test. Might throw some Pythagorean theorem in there just for fun, but this is our special right triangle unit. So here's the 30-degree angle, and let's say I give you this side right here is 5 square root of 6 centimeters. So that's the short side. That's the side that's across from the 30-degree angle, so it goes there in the table. In order to find this one, I would do 2 times 5 square root of 6, and the only thing I can do there is the 2 times 5. So this length is 10 square root of 6 centimeters. And then this length right here, I would have to take my x value and then multiply it by the square root of 3. So we're going to end up with 5 square root of 6 times the square root of 3. I can multiply those two square roots by each other, but we always have to ask ourselves, is that value inside the square root something that can be simplified? And in this case it is, because 18 is 9 times 2. I know that the square root of 9 is 3, so I'm going to take the square root of 9, which is 3, and I'm left with just a 2 inside the square root. So that simplifies to 15 square root of 2. That would be this length right here. Okay? So now that I have all those lengths, I can find the area and the perimeter. The area of the triangle is base times height divided by 2. So 15 square root of 6 times 15 square root of 2 divided by 2. I said 15 square root of 6, I meant 5. So I can multiply the 5 times 15. I'm going to get 75. So 75 square root of 12, because now I'm multiplying the two square roots by each other, divided by 2. But I can simplify square root of 12, because square root of 12 has a perfect square factor, which is 4 times 3, where 4 is the perfect square. I'm going to take the square root of the 4, that's a 2. So now I have 2 times 75 square root of 3 divided by 2. I'm going to simplify right here. Multiplying by 2 and dividing by 2 will cancel each other out. So my final value for area here is 75 square root of 3 square centimeters. So doing a little bit of radical simplification along the way just to review. And then to get the perimeter, I'm going to add up all the sides and I'm going to look for like terms. So I have 5 square root of 6 plus 10 square root of 6. Whoops, those are like terms. I'm going to be able to combine them. Plus 15 square root of 2. That one's not a like term. So I am going to be able to add these two that have the common factor square root of 6. And I'm going to end up with 15 square root of 6 because I'm just adding plus 15 square root of 2 centimeters. And that is the final value for the perimeter of this triangle. And that is how we find perimeter and area using exact answers and special right triangles. Have a great day.